Exercise 21.3, question 12. So in this situation, we've got a ball being kicked at an angle of theta and a speed of u. And what we are given is we're given that the height here is 4 and the distance here is 32. And we're also given that theta is tan inverse of 3/4. And we need to resist the temptation there to just say, put that into our calculator and find a value for theta, because we're going to lose some accuracy. So let's think about what we do know. We do know that if we're thinking about the point when the ball hits the wall, we do know that r is equal to 32/4. And as always, we know that a is 0 minus g, as gravity is the only force acting. And if we think about the components of the initial velocity, well, the horizontal component here is u cos theta, and the vertical component here is u sine theta. So if we think about what we know here, we know that if we take tan of both sides of this, we know that tan theta is 3/4. Well, we can use our knowledge of right-angled triangles to find out cos theta and sine theta. So if we draw a triangle and we know that the tan theta is the opposite over the adjacent, so we draw an angle with theta here and an opposite of 3 and an adjacent of 4. The hypotenuse by Pythagoras' theorem is 5. So we know that cos theta is the adjacent over the hypotenuse, so cos theta is 4/5, and sine theta is 3/5. Okay, so that helps us a bit with finding the initial velocity. The initial velocity is u sine theta, but u cos theta. U cos theta, but that is just u times 4/5, so it's 4u/5, and then u sine theta, which is going to be u times 3/5, so 3u/5. Okay, so we have r, a, and u, so we put that into our Suvat equation of r equals ut plus a half a t squared. We get 32/4 equals 4u/5, 3u/5 plus a half 0 minus g t squared. And firstly, let's take the horizontal component of this. So we're taking the horizontal component, we get 32 equals 4u/5. So 32 equals 4u/5. Solving that gives us times by t, so I'm missing a t here, so 4ut equals over 5 equals 32. So solving that for t in terms of u, we get t equals 40/u. Now we can take the horizontal, the vertical component. So we get 4 equals 3u/5 times t minus g/2 t squared, but we can just substitute in this value of t here to get an equation in u. So 4 equals 3u/5 times by 40/u minus g/2 40/u all squared. Well, doing a bit of simplifying, we can see that the u's here cancel. The u's cancel there. 40 divided by 5 is 8, so we get 3 times 8, and we know that 3 times 8 is 24, So actually, what have we got? We have 24 minus g over 2 all multiplied by 30 over u squared equals to 4. Okay, so that must mean that g over 2 multiplied by 40 over u squared is equal to 20, and therefore g over 2, 40 over u all squared is equal to 40 over g. Taking a square root, 40 over u equals root 40. Root 40 is 2 root 10 over root g. Reciprocating and dividing by 40, we get u equals root g. Reciprocating and multiplying by 40, we get root g over 2 root 10 times by 40 equals u. So actually u equals 20 root g over root 10. Rationalising the denominator of that by multiplying by root 10 over root 10 gives us u equals 2 root 10g, which is approximately 19.8 meters per second. Okay, the second part of the question asks us for the velocity with which it hits the wall. So it wants the velocity. Actually, it doesn't want the velocity, it just wants the speed, which is slightly easier. Here, and notice on my diagram that looks as if it's horizontal, but it may not be. It may actually hit on the incline like this, or it actually may hit when it's descending like this. But what we do know is we've now found u. So actually we can go to a different Suvat equation, because we know a relationship between v and u. We know that v equals u plus a t. Well, we do know u. We know that u was equal to u cos theta u sine theta. But now we know what that is. We know that that is 2 root 10g. Cos theta was 4/5 times by 4/5, and then 2 root 10g times by sine theta, which was 3/5. We still know a. We still know that a is 0 minus g. And we worked out what t was. We worked out that t was equal to something up here. T is equal to 40 over u. So t equals 40 over u, but we have calculated this u. That u was 2 root 10g. So actually we know that t equals 40 over 2 root 10g, which is 20 over root 10g. And let's rationalise that. That is times by root 10g over root 10g, which gives us 20 root 10g over 10g. Well, that's 20 divided by 10 is 2. That is 2 root 10g all over g. Okay, so if we put that in to our v equals u plus at, we get v equals, and let's take this u here, and let's take a factor out of 2 root 10g over 5. That's going to make that look a lot nicer. So we're going to get V equals U, which is 2 root 10g over 5 multiplied by what was the vector that was left. It's going to be 4 and 3. V equals U plus A t. So 0 minus g is A. And then t is 2 root 10 g all over g. And now we can just go about simplifying this. So what are we going to have? Well, if you notice as a whole, we can take a factor of 2 root 10g. So this is equal to 2 root 10g brackets and then 1/5 of 3 and then plus 1 over g lots of 0 minus g. And simplifying that even further, we get 2 root 10g, and then this factor here is going to be 4/5 plus 0, and then 3/5, and then 1 over g times minus g is minus 1. So 3/5 minus 1, 3/5 minus 1 is minus 2/5. Okay, well, it looks useful to factorise 2/5 here. So if we take out 2/5, we get 4/5 of root 10g. And then we're taking out 2/5 here, so that is 2, and that is minus 1. So that is our velocity when it hits the wall. The question actually asks for the speed, so we want to find the modulus of this. So we want the modulus of this whole thing, the modulus of this whole thing, the modulus of this whole thing, the modulus of this whole thing. Well, the 4/5 root 10g is just a scalar, so that can come out of our modulus. So it's 4/5 root 10g multiplied by the modulus of 2 minus 1. Well, that is 4/5 of root 10g multiplied by the square root of 2 squared plus negative 1 squared, which is root 5. So we end up actually getting 4 root 10g root 5 all over 5, which is actually 4 root 50g all over 5. And putting that into your calculator, you get 17.7 meters per second.